Hi everyone. This is 4.5 part 2. In part 1 we learned a lot. We learned about what trigonometry is, we learned about SOHCAHTOA, opposite, adjacent, hypotenuse. Um, Today we're going to take it one step further and we're going to use SOHCAHTOA to find missing sides in triangles. So let's start off really quickly by what we already know. We know from earlier in the year, if you know two sides of a right triangle, you can find the third one using Pythagorean theorem. You don't need SOHCAHTOA. You just do a squared plus b squared equals c squared, you got your third side. Now this is going to be a new problem you haven't seen before. If you know one side and one angle, not counting the right angle, one of the two acute angles. So you already have the right angle. If you know one side and one other angle, then you can find another side using SOHCAHTOA, and I want to show you how to do that today. So here are the steps. Number 1 from yesterday, label the sides opposite, adjacent, and hypotenuse. Number 2, we're going to use SOHCAHTOA, but we're going to kind of use it backwards. We're going to look at the triangle. We're going to say, okay, which is the side I'm trying to find? Which is the side I know? Because remember, I said you know one side automatically. So of those two sides, you're going to pick the right trig function using SOHCAHTOA. So let's say, for example, the side that I know is opposite, and the side I'm trying to find is hypotenuse. Well, opposite and hypotenuse is here, so I would have to use sine. But in a different question, maybe the side I'm trying to find is adjacent, and the side I know is opposite. That would be a tangent question. So depending on the two that you're using, you have to use two. You have to use the one that was given in the question and the one you're trying to find. Depending on which two those are, you have to use that to pick the right trig function, sine, cosine, or tangent. Now, after you do that, you set up the trig ratio just like we did yesterday in part 1. And I said, remember, when you're setting up a trig ratio, we said after you write sine, cosine, or tangent comes the angle from the problem. So you're never just going to write cosine and stop. You're going to write cosine, then an angle, like cosine 20, like I said here, or whatever the angle is. And then you solve for x. And solving for x is like we've been doing. It's like canceling. I want to multiply to cancel this. I want to add this to both sides. Whatever you need to do to solve for x. The difference is after you've solved for x at the end of a question, you're going to use a calculator for the trig function part. You're going to use the calculator and type in cosine of 20, or whatever that trig function was. So before we do a full example, I want to show you how these are going to end up. When you set up your trig equation from the triangle, after you've done all the work, you did opposite, adjacent, hypotenuse, you pick the right trig function, you put the angle in, you set up the ratio right, you do all the work, it's going to look like one of these two things. It might say, and I just made up numbers for this, it could have been any trig function at any angle, but it might have said cosine of 37 equals x over 12, or it might be something like tangent of 81.4 degrees equals 21 over x. Now the difference here is that in the first one, the x is on top. When x is on top of the fraction, that actually makes the question a little easier. In the second one, the x is on the bottom, and that takes one extra step to solve. So let's actually, on the next slide, we're going to work these two out. We're going to take these two equations and solve each one for x, and then we'll talk about a little bit of a shortcut on the second one. So here's our same two equations. Let's start with the easy one. I said the first one where x is on top is easier. The reason it's easier is if x is on top, if I'm trying to solve for x and I have x over 12, x over 12 means divided by 12. And you can cancel out a divided by 12 with a times 12. So the first one I can solve in one step. I just multiply both sides by 12. On the right-hand side, dividing by 12 and multiplying by 12 cancel, and it just leaves x. On the left-hand side is the answer to the question, 12 times cosine of 37. And like I said, at this point, this is not like the 30, 60, 90s or anything like that. This is just use a calculator for that. There's no shortcuts here. So I'm going to pause and do the work on a calculator. I'll come right back. Okay, so I did that on a calculator, and I got about 9.6 for that one. So our first answer would be 9.6. And one step, multiply by 12 and you're done. Now, let's look at the second one. I said the second one's a little harder because you can't do it in one step. You can't just divide by 21 or multiply. You got to get that x out of the denominator before you can solve for it. You can't solve for x if it's in the bottom of the fraction. Now, the first step is going to be kind of like what we did on the first part. I'm going to say, I want to break up that fraction. If I want to get that x out of the denominator, I want to cancel it out. Well, the way you cancel out something just like our 12 from before, if I want to cancel an x in the denominator, I'm going to multiply both sides by x. Now on the right-hand side, this x cancels with this one and just leaves the number 21. On the left-hand side, you have exactly what you see. You have x times tangent of 81.4. Now remember, I said this one's a little harder because it's one extra step. We're not done. We don't just multiply by x and we're done. We still have to solve for x. So I have x times tangent of 81.4. If I want to cancel that tangent of 81.4, I'm going to divide. So I'm going to divide both sides by the tangent of 81.4 degrees. This whole thing cancels with this whole thing, and see, it just leaves the x. So that's the answer to the question, is 21 over or divided by tangent of 81.4. Now here is where you would do it on a calculator again. You would grab a calculator and do 21 divided by tangent of 81.4. I actually did it already the first time I paused to go to my calculator, and it comes out to about 3.2. All right, so you're looking at the work right now. In purple, easy, one step. If x is on top, you just multiply and you're done. In blue, it took two steps. I had to multiply to get the x out. Then I had to divide to get rid of the trig function. Now, I did tell you there's kind of a shortcut to this, so let me erase my work and I'll show you what I was talking about. If I go back to the original problem here, what I did is I multiplied, which basically took this x over here, and then I divided, which took the trig function back here. So it's kind of a shortcut here since you realize you're going to do the same thing every time. If I'm just multiplying and taking the x over here, and then dividing and putting the tangent of 81.4 back where the x is, instead of doing it in two separate steps, you can just, in one step, just switch those two things. So let me put that into writing for the notes. I said, number one, if you go to solve a trig equation and the x is on top, that's the easier one. Just multiply by whatever was underneath it and you're done. Now, if the x is on the bottom of the fraction, what you do is you switch it with the trig function. Just take the x from the bottom, put it over here, take the sine or cosine tangent, whatever it is, and put it where the x was. And then you're done in one step instead of two. So let's finish up with a word problem here. We have, how tall is the building? And instead of making it a word problem, I kind of turn it into a picture. But the word problem would say something like, you are standing 57 feet away from a building. The angle from you up to the top of the building is 55 degrees. How tall is the building? Basically what it's saying is, in this picture, if I call this side of the triangle x, solve for x. So let's see if we can do that. I just told you in the notes how to do that. So step one was to label your sides. Since the right angle is down there in the bottom left corner where the building meets the ground, this right here would be the hypotenuse. Now the 55 is the angle. That's the one I'm using in the question. That makes this side over here, x, the opposite. And the 57 would be the adjacent. So just like yesterday, step one was figure out which side is opposite, which side is adjacent, which side is hypotenuse. Now, step two, this is what's new for today. We're going to go back to SOHCAHTOA, just like we did yesterday, but instead of me saying, okay, I want you to do sine, which sides do you use? We're doing it backwards. We're saying, which sides are we using? Which trig function do we need? So for this question right here, the x is opposite. I need to use that. The 57 is adjacent. I need to use that. That's O and A. Well, O and A right here tell me that I need to use tangent. So this is a tangent problem. Now, if you're only using those two sides, it's the only one that works. See, I don't know what the hypotenuse is. Let's notice that first. I don't have any idea how long this side is, so I have no number to plug in for h. Well, that means I can't use sine, because I need hypotenuse for that, and I can't use cosine, because I need hypotenuse for that. So tangent is the only one that works. If I want to use opposite and adjacent, this is a tangent question, period. There's no way around it. So that's step one, is picking the right trig function to solve the question. It's tangent. Now, the other thing I told you, after you pick the trig function, sine, cosine, or tangent, immediately write the angle after it. So the angle in this problem is 55 degrees. Now, I go back to SOHCAHTOA again. TOA, tangent equals opposite over adjacent. Opposite in this question is x, and adjacent is 57. So there's my question. Now, we've turned it from a problem into an equation to solve. We know what to do now. That's what we just talked about in the last one. The next question you ask yourself is, where is the x? If the x is on top, like this one, it's an easy question. If the x is on bottom, we got to do that switch. So for this one, I don't need to switch anything. I can cancel out that 57 by multiplying both sides of the equation by 57. So I multiply by 57, that cancels with that and leaves just the x. The answer is 57 times tangent of 55. And I'll just go back to my calculator one more time. I'm going to pause and do that. It's about 84.7. So in that picture, that building is about 84.7 feet tall. If you're 57 feet away from a building, and the angle up to the top of the building is 55 degrees, based just on those two measurements, you can find the height of the building. We rounded it off, it's about 84.7 feet. So that's how SOHCAHTOA works, not just to set up an equation like we did in part one, not just say, okay, tangent equals opposite over adjacent, let's just put the numbers in and move on. Now all of a sudden we are using them to find missing parts of triangles.